I'm with Matt Francis from DLF Seeds, and we're in southwest Victoria looking at field trials of genetically modified white clovers, which have originally been based off a New Zealand clover species, and they've been genetically modified to produce high condensed tannins, which ultimately will result in livestock producing lower methane emissions when they consume it, and also have fewer bloat issues, which plenty of dairy farmers will be able to relate to when feeding clover. And in the trials, DLF Seeds are working in a joint venture with Grasslanz New Zealand, and this may ultimately, what we're looking at, ultimately become the first iteration of a commercially released GMO variety of white clover. Matt, thanks for taking the time to take me out today and catch up. Richard. Yeah, and I appreciate it. And I was wondering, maybe you could just take us through some of the steps that have taken you to get to this point here today with these the predecessors of what may be some commercial variety.
Yeah, no problem. So the research for this dates way back until sort of early 2010s, and so initially they took a gene from hare's foot clover and inserted it into a commercial variety of white clover. And so that gene allows the plant to express high levels of condensed tannins, and essentially what that allows the plants to do is it massively reduces methane emissions, and it also prevents bloat in animals. And so to get to this point, it's taken sort of more than a decade of research, and so following the initial insertion, there's been a ton of work done in the greenhouse to select plants for vigor, because when you insert that gene, then there's a bit of a yield penalty we've noticed, and so the plants sort of lack vigor, and so there's a bit of
a trade-off between the tannins versus the yield in the plant.
Yeah, absolutely. And there's also a range of expression of the tannins, and so there's plants that almost don't express it at all, and then plants that express a high level of condensed tannins. And so the breeding focus has really been to sort of bump the level of condensed tannins up to an acceptable level where you'll see noticeable impact, and then also to breed for vigor, so the plants will be robust and be able to survive.
And how much have you been able to close the gap between your commercial baseline and where you're at now? Have you managed to
so we're getting close. So I was involved in the project, the first field trial that went in the United States back in 2018. The plants really lacked vigor, but after a few cycles of selection, we're getting up to probably within 10 or 20% of where a commercial cultivar
which is getting within shouting range, isn't it?
Yeah, absolutely.
Commercially, and I guess the upside is that the gains on methane emission, you'll be looking at that point where that is greater than any loss of productivity that you get in the plant.
No, exactly. And that's sort of where we're at this stage. And so what you're looking at here is the next generation. So after about a decade of breeding, we're sort of at the point now where we're putting in sort of the final stages of a field trial. And then so this will be the foundation population where the seed will be developed and increased. And
So from here, where do these plants go from here then, Matt?
So we've got a site here in southwest Victoria where we have a contained greenhouse, where these will be planted into the field there, and we will evaluate them for tannins and yield again, and then we'll increase seed there, and then from here we'll be looking at animal testing to sort of get real effects on feed quality, feed yields, and animal improvement.
Exciting times. Realistically, if they get over all those other hoops, animal testing and no other downsides, what sort of time frame do you think to become commercially available?
That's a great question. I guess it depends on where New Zealand is and Australia is with the regulatory component. So there's obviously that battle to go through. Seed production. So obviously there's only a few thousand plants here. You need to ramp up seed production and the animal testing. Probably still, I would estimate more than a decade away from having a product commercially available, but I mean it could be sooner if those loopholes are easy to sort of jump through, and we can get through the regulatory.
Do you think it would make easier if New Zealand's GE regulations were more in line with Australia's? Would that help, do you think?
I think that would be a big difference. So obviously this is bred out in New Zealand, first developed in New Zealand.
Was from there, wasn't it?
A lot of all the people sort of who developed this project are based in New Zealand still, and so there's a lot of collaboration between the two countries there. So I think that would help a lot as far as fast tracking the process.
Well, we're due for a timeline on our genetic engineering regulations, so maybe we'll see some unity come out of it.
I mean it's certainly an exciting project to work on, and it has massive upsides for New Zealand agriculture. So
great. No, thanks, Matt.
Cool. Thanks, Richard.